Dear students, welcome to this um, semester 6 of BE Civil Engineering. So I am going to handle structural analysis 2 in continuation with the 5th semester subject structural analysis 1. Compared to structural analysis 1, I felt that structural analysis 2 will be easier to you. So before going to the syllabus discussion, let us revise the vision of our civil engineering department, because each student should know the vision of the civil engineering department and what are the ways the mission is going through to achieve this vision. So the first of all, our vision is to offer novel and economical solutions for the complex and complicated problems arise in civil engineering industry. So there are a lot of problems related to sustainability and design of various structural elements, and in construction management sites there are a lot of problems will arise. So we have to give some economical solution, not even the solution. We need some economical solution for the complex problems and to play a significant role in the developing the infrastructure in our country. So it is already we have well known to this point, and to provide a creative environment for learners to attain high level of excellence in the civil engineering industry. If you are given with a practical problem, you should deal as the situation, not as the problem. So in structural analysis point of view, in classrooms we will take one problem and we will solve for the solution, that is shear force, bending moment values. But in real cases we should see the same image as a real one, and how the loads are going to be applied, and in which direction the loads will be significant. So those are all the points we have to be clear. The mission of our civil engineering department is to create, disseminate, the integrate in-depth knowledge in civil engineering among graduates, and to provide a dynamic learning environment that emphasizes open-ended design, problem-solving skills, teamwork, communication, and leadership skills, which in turn enables the betterment of human society, and to produce highly competent civil engineering professionals with innovative thinking and ethical standards, to promote quality education, research, consultancy for industrial and societal needs, and to provide state-of-the-art resources that contribute to the congenial learning environment. So these are the ways how we can achieve the vision of our civil engineering department. There are a lot of points included to achieve the vision here. Next one, program outcomes. Total 11 program outcomes are given by National Board of Accreditation for getting the accreditation for a particular programs. So civil engineering is a program. So these 11 program outcomes are expected while the students completing the program. So the PO1 is basic understanding and remembering level, because we already studied maths, science and fundamental concepts. So the PO1 should relate with the remembering and understanding level of existing knowledge. PO2 starts from the problem analysis. So our civil engineering subjects, major subjects RCC, design of steel structure, and analysis 1, 2, mechanics of solids, engineering mechanics. Most of the subjects are related with this problem analysis, because we are identifying the problem, formulating and research literature. Based on this, we are analyzing the complex engineering problems. Next one, PO3, we are making designs. In RCC and steel, we are making design. So this PO is completed with the subjects DRC and design of steel structure. We can map the maximum value of 3 for the design subjects like RCC and steel. So PO3 is design or development of solutions. The design solutions for complex problems considering public health, safety, societal needs and environmental impact. Next one, PO4, laboratory subjects can be mapped with the PO4 because of we are conducting the investigations for the complex problems. So use research-based knowledge and methods to investigate complex problems. PO5, engineering tool usage. Our STAT4 laboratory, so such software, Word, Excel, basic computer laboratories. These are laboratories can map for PO5 fully because we are using some specific softwares and engineering tools. Next one, PO6, the engineer and the word. Apply reasoning informed by the broad context of engineering including sustainability and societal impact. So all the subjects related with sustainability, maximum environmental subjects and the construction management subjects can be mapped for PO6. And PO7, ethics, some management principles, professional ethics subjects can be mapped for PO7 fully. The ethical principles are coming under this program outcomes. Next one, PO8, individual and collaborative teamwork. So the laboratory classes and the project works can be mapped for this PO8 with the individual or some group activities. And PO9, the communication. If we are undertaking a English laboratory, then we can map PO9. But our civil engineering program does not, except during first year of study, there is no specific subject for the communication development. So we have to map PO9 by conducting seminars, by giving seminars for you students, or by arranging some group discussion or a particular topic. We have to map PO9 in each subject. Next one, PO10, project management and finance. So this component can be mapped in project works. And PO11, lifelong learning. If any subject is connected with the GATE syllabus, we can map lifelong learning, because if a subject needs lifelong study for its application, we can map PO11. So by having some understanding, we can map PO2 to PO11 for a particular subject. Our analysis subject mostly mapped with PO2 because of problem analysis. Some subjects like DRC and steel mapped fully with design and development solutions. And at the same analysis subject, we can map PO9 by giving some seminars and quizzes. Next one, program specific outcomes. Here, this program specific outcomes varies subject to subject, program to program. Sorry, it does not vary subject to subject, but it varies program to program. BE Civil Engineering will have specific PSO, ME Structural Engineering will have specific PSO, but each subjects in BE Civil Engineering will have same PSO. So our program specific outcome 1 is prepare, plan and layout for any civil engineering structures. While you are finishing your final year of study, you should prepare plans and layouts for any building types, and analysis and economically design the safe and durable structures, because most of the subjects we are having design and analysis. So you have to know how to design a particular component. Next one, investigate issues pertaining to water treatment and waste management. If you are go through the curriculum, most of the subjects are coming under any of these three categories. So we have included water treatment, water management related subjects in PSO. Next one, coming to our subjects 22 CEC 61 structural analysis 2. The course objective is analyzing determinate and indeterminate structures using ILD, and analyzing the arches, cables, suspension bridges and plastic analysis. So we can identify the three major divisions. First one, analyzing determinate and indeterminate structures using ILD. So first and second unit will deal with the ILD, and third and fourth unit will deal with the arches, cables and suspension bridges. So these three components will coming under a single heading. And fifth unit will be the plastic analysis of the structures. So we can divide into three major parts. Next one, course outcomes. In this course outcomes, you can identify the CO1 to CO4 will be related to any one of the units, and CO5 does not related to a particular unit. By solving the problems, we can give some seminars and it can be evaluated internally. CO5 is going to be evaluated internally, because if you look at the CO1, summarize the concepts of ILD for determinate indeterminate beams, also summarize the concept of arches, cables and suspension bridges. If you are looking into the question paper, you can relate CO1 for in any unit. In the previous system, we will have unit 1 as CO1, unit 2 as CO2, unit 3 as CO3, unit 4 as CO5, unit 5 as CO5. But now onwards, we have changed a lot in the question pattern. So unit 1 to 5 will consist of any one of the CO1 from CO1 to CO4. It will not consisting of CO5 because it is internally going to be internally evaluated, but nothing more difference than that. The first unit is influence lines for determinate beams. So statically determinate beams only we are going to consider, only simply supported beam. Next one, some part will have overhanging or both the parts will have overhanging. With the different loading conditions. Actually, this concept is dealing with the moving loads. The load is first in this position, next it moves to the next position, and it further moves to this position. So the load is not considered to be static at a point. It is actually, I am hanging the load above the beam. I am not placing the load over the beam. I am hanging the load over the beam. That is, I am considering that the load is moving from left to right or right to left. And generally, in our, for our comfortness, we are considering the load is moving from left to right. That is, if you are considering a bridge, a vehicle is traveling from left to right, and it has number of wheels. Each wheel is considered to be a point load. Then initially this truck will be here. Finally, the truck will leave on the right side. Finally the truck will leave on right side. The wheels are located like this, and the load is applied on each wheel as the axle load. So here it is entering, here it is leaving. So the load direction is from left to right side. The load is travelled from left to right side. So this loading condition is considered to be multiple point loads moving from left to right of the bridge. Multiple point loads moving from left to right side of the bridge. This point load may not be same in the magnitude. Here it can be 50 kilonewton, next one 60 kilonewton, next one 80 kilonewton, next one 20 kilonewton, and next one 20 kilonewton. Why I am giving approximately lower value of 20 kilonewton compared to the others? Because the material is loaded only at this part. So this point load will have lesser load, application of load compared to backside wheels. So I am approximately giving lesser value for this wheels. So this load is coming as multiple point loads. We have some different point loads. Basically, a single point load is considered to be moving from left to right. Next one, uniformly distributed load larger than the span is moving from left to right, and uniformly distributed load of smaller span moving from left to right, and the two wheel axis moving from left to right, and multiple axis moving from left to right. In multiple axis loads, we may have some UDL also. If you are given with the problem, this span or these distances are fixed. Because the distance between the wheels of a vehicle are always fixed. It will not vary while moving from left to right. It is fixed. That is the condition. Here the span does not vary. Here it is a point load. In 2-point load, the distance between the loads are constant. So the distance between the loads are constant. It is totally moving from left to right. So in this case, we are going to apply any of the condition. That is, what is the condition to get maximum positive shear force, and what is the condition to get maximum negative shear force, and what is the condition to get maximum negative bending moment, and what is the condition to get maximum positive bending moment at a given section. Given section means you are asked to find maximum positive bending moment, maximum negative bending moment, or maximum positive shear force, maximum negative shear force at some x distance, maybe 5 meter from the left end. So you will be given a section to find out these categories. In the next aspect, absolute maximum positive shear, and so I can give this is 5. Next one 6, absolute maximum negative shear force and absolute maximum bending moment. So these are all absolute values, that is maximum of maximum shear force values. When you place a load here, you will get some maximum negative shear and positive shear. When you remove this and place the same load, when you remove this and place the same load here, you will get different shear, maximum and negative and positive shear force. And you are again removing this load and you are placing the load right to the section. Here it is the XX section lies, and you are placing the load on right side. What is the maximum negative and positive shear force? And again you are removing and you are placing the same load here, and what is the maximum and negative shear force. In these all cases, you will get some values. You will get some increasing trend or decreasing trend. The absolute maximum negative shear and positive shear is the shear of maximum all possibilities while you are placing the load in the span. So with this introduction, I am moving to the next unit. So this is also ILD, that is for indefinite beam. So normally the indefinite beams require some new concept or new principle. So here Muller-Rössler principle is used, and for this if you are taking a property cantilever, it is an indefinite structure. So we are going to remove this reaction and we are going to apply 1 kilonewton load in the same direction, and we are going to have some integration in this unit, and we are going to draw the ILD diagram. So in unit 1 also we are going to draw an influence line for shear force and bending moment diagram. So influence lines mean it means that here I am considering 50 kilonewton load and I am going to draw the shear force diagram like this. This is negative diagram, this is positive diagram. In the influence line, we are not going to deal with 50 kilonewton. We are going to deal with 1 kilonewton load, and we are going to estimate the same positive and negative shear force at this section with this 1 kilonewton. So it is very easy for the calculation for the design engineers dealing with 1 kilonewton rather than 50 kilonewton. So that is the ILT concept, influence line concept. This is very simple for design engineer, so it is mostly adopted. So in moving load concept, we are going to apply 1 kilonewton instead of actual loading, and finally we are going to multiply the 50 kilonewton at the last step. So we will see one by one while having further lectures. Next one, arches. Arches, you already know it is a arch profile. Arch profile will have 2 hinged arch at the supports or 3 hinged arch. It is having some additional hinge at the crown point, and calculating the bending moment and shear force, radial thrust and radial shear and normal thrust also can be calculated. So this is all about the arches. Next one, cables and suspension bridges. So we know the suspension cable bridges tied with the cables. So each cable will have some tensile force. So we are going to analyze with the different support conditions and calculating the bending moment values. Next one, plastic analysis. It is completely different from normal analysis, because from strength of material, mechanics of solids, all analysis problem we are assuming that it is elastic. All the conditions are within the elastic limit. Beyond that, we have one region while we are testing the mild steel. This is the elastic limit where the Young's modulus, the stress is proportional to strain, and further this is the plastic region. Before collapse we will have some strain hardening portion. The strain is hardening. If it is stress, here it is strain. Basically the stress is increased with the particular strain value. Both the ratios are same within the elastic limit. Beyond this point, the stress is not increasing. The stress is limited. The stress is not increasing, but the strain is increasing. Sudden collapse will not occur. The strain is increasing and it gives some warning. So this portion is called strain hardening portion. So this portion is also called plastic region. Plastic region after the formation of some hinges, because the hinge allows enormous rotation at this point, at any point. So this enormous rotation will leads to collapse. So at this point the structure will collapse. So from the linearity point to the collapse, we have the plastic region. So here we can calculate maximum collapse load. Maximum collapse load. Up to this point we will talk about the yield load or yield stress. Here in this region we have to calculate maximum collapse load or maximum bending moment, ultimate bending moment. We have two theorems, upper and lower bound theorems, to calculate this. So these are about the unit wise discussion. So these books you can refer further. And this is the mapping. PO1, actually the CO1 should be taken in understanding and remembering level. Only 2 marks can be asked in CO1 from the all units. The 2 marks will have CO1 only. It can be asked from all units. Each unit 2 questions. That pattern didn't change. Next is PO1. CO2 is mapped with PO1. Actually this should be mapped with PO2 only, because PO1 is engineering knowledge. Always we are applying engineering knowledge. So CO2 is mapped with PO1, further CO3 PO2, CO4 PO3, and CO5 by giving seminars, communication, PO9 communication can be employed, and PO10 and PO12 lifelong learning. Here it is teamwork can be mapped in CO5. So this CO5 can be evaluated internally. It will not be asked in examination. Okay, thank you. So with this introduction, we will move on to the further lectures.